Welcome to another video on my Arduino Mega2560 with Arduino Uno connected through SPI, serial peripheral interface, and several fischertechnik mechanics motors driven by pulses modulation. When I prepared for this experiment using this oscilloscope, I noticed something remarkable. Using this probe, of which you see the signal on the scope, I removed it, and you see that the motor, the left motor, is halted. Now I connect it again, and you see that the motor is running. So how is this possible? Well, I like that it runs anyway. And it should run. And when I only do this, there's something else going on also. So this is right, and now this isn't right anymore. Yeah, because the wire is out. So I have to be really careful with these things. Clearly. And now they run again. So that is one thing. Then the question is this signal really the signal I'm looking for? That is really what I wonder. So this is again another signal, and now I am mainly probing the transistor, or am I? Now I'm just touching the transistor, touching the wire, and does the motor run? Not really. So I hook everything up. Now it runs, and fast. But how do I explain all this? I already changed the time base, because a time base is how you, if I'm getting it right, how many seconds you see in here. So these are many pulses, and now I am getting even less pulses in the same time. The only thing I regret is now they are wider and still wider. I turn left and there are more pulses. There you can, so this is time base. You see more pulses on screen. What I would like to see is everything widened, but I haven't been able to do that yet. Must be possible, of course, but so far this is what I get. What I'm happy with is that everything works, kind of. So no electronic problems. So what's next? Well, a better view of the scope, of course, and of course the SPI, but that comes later. Interesting is also the wave that I would get when I probe for this motor. So I have put ready another probe, but I have yet to select this channel. So now I am going to get this probe. And what I do have to take care of is, of course, that this mechanism keeps running. And now for some, I have taken the complete transistor off. That is, of course, not the intention. And this, and alright, yes, and it runs again, but this shows that I have to be really careful with the signals that I probe, because the transistors don't have very long wires. So what I actually should do is put some wire next to the transistor in the same lane, so I can safely hook up. And I should actually do the same right in this circuit. So here I have a wire, and I will try to put it nicely in the same lane. If that works, hook it up, and it won't fit, unfortunately. I need something more rigid. I should do this off camera, but it's running anyway, so now this could be it. And then hooking up the probe. There you go. Getting this to work. And now you see, by the way, that when the motors are standing still for some reason, that everything else is just going on. So now the motors are running. Let me show you. Everything is running. The probes are hooked up. And the signals are quite clear, and this signal is very clear even. But now there's a problem. This is DC. It's not selected to whatever it is. So this signal, although nice to see, is not pulse width, and that is needed. So I have to set this. I have now in both transistor circuits put a wire in the same lane as the transistor, connect in the same lane as these wires. And the remarkable thing is that well, channel 2 is now put on pulse as well, the same setting, and this is a difference. Now that is very well possible because when I look here, they have different values. So the pulse width modulation values are different. That is not such a problem. However, what is a problem is that right now, whenever this motor is working and gripping, the motors don't work. So when I lose this and I get a grip on the whole thing, and I have to take care that I do not lose the entire circuit again. So now this is working. I hook this one up, but this is another one. This is the left one. So what makes everything run or not? That is the big question. Also, when I touch it, is there a difference? Now this is yellow and this is blue. Do both motors work? Not right now. Certainly not this one. So it is still a mystery to me why sometimes the motors do work and sometimes they don't. Also here, oh by the way, this is the blue, this is yellow, this is blue. So what's the reason of the signal change? Really remarkable. Still have to find it out. Apparently I still have to get acquainted to the whole thing. So let me get lost of the yellow one for now, which is this motor, and I have to change the wires a little bit. Let me be very careful. This one needs to be in here. And then this one I will put in front of it, if it lets me, and it should. Alright. Now I am measuring the signal. Or am I? No, I'm not. And this is all experimenting. But this motor isn't working again because I have, for some reason, this in the wrong place. But if this is the pulse width modulation, it's quite a rugged signal, not a nice block wave, so I have to still find out how to get that. But it's nice to have some signals and to see that they are different, because the settings are different, and then I mean the settings in the code. Alright, coming up next, pulse width modulation, because that I can measure with the oscilloscope as well. In order to measure serial peripheral interface with oscilloscope, I have to apply several settings. First, I have to make sure that the type I'm triggered, I require the trigger for, is actually SPI. Then SCL, well, SCL, serial clock, that's fine, channel 1, zero line. So what I have done here, although it's not very good visible, one new wire applied into a second ground pin, and then this probe connected to the SCL wire. Then a piece of mystery, because as also this manual says, you need SDA. Now that's a bit of confusing, because there's no SDA in here. There's master output slave input, master input slave output, serial clock slave select. So what is SDA? Yes, according to the manual, I have put it on channel 2, and this is channel 2 probe, not connected yet. So, very big question. What is sending it? Data line setting. Yeah, right. So I assume SDA is for data, and then I have to set the number of bits of the serial data character string. Well, this serial data character string is not as much as a mystery, because let me look here. This SPI test, which I have been using for quite a while now to test the whole sequence, is a character string. It's my data. So, alright, SDA is my data. Is SPI test what which I have to do, and that is 1, 2, 3 for SPI, space is 4, TST is another 4, slash N is another 2, so 8 plus 8 plus 2 is 10 characters. Oh, not so fast, because I am sending a 0 as well. 11 characters. So SDA should be 11 characters then. Alright. Now, back here. Set the number of bits of the serial number of bits. Well, a character is 8 bits. Oh. Wait a second. Considering a normal byte. No, the number of bits. Yeah, that's 8 bits. 1 byte. Each character is a byte. Each character is a byte. 1 byte, 8 bits. So that's a nice one. Considering the 11 characters, 11 times 8 is 88 characters. Can be set by any integer between 4 and 32. Ooh, ouch. How to solve this one? Am I thinking the right way anyway? Considering this explanation, I'm not. That's a very good one. But now for an answer. That may be just something different. And also, what am I sending anyway? Slave select. Master output slave input. What is SDA to measure? I think it should be 11 then. Just an idea. 11. But once again, this is, I have to give this some very serious thoughts. Alright, back to the drawing board once again. Alright, some thinking done. First of all, this probe has now been hooked up to 11, master output slave input. no idea yet if that is actually alright. But some other thoughts. Data bits is the number of byte. It's the number of bits per byte, not total number. That said, any integer, well, 32 bits, data bits, that is in normal reckoning, standard reckoning I should say, divided by 8 is 4 bytes. However, I just take it as 8. Current bit, set number of data bit and the range from 0 to, well, those specified in data bits -1, which makes it 7, and so it can be set from 0 to 7, which is 8 in this case. And data either high being 1, low being 0, or X don't care. So that is what I think it is now, without going through all tutorials, etc. So looking here, I go to data and I can see 8 data bits, 1 is the current bit, and don't care, and I didn't change a thing about it. So with that done, if I now actually look here, we'll see some data being sent, I think, but let me check first if anything is being sent at all. Now, before doing that, when I set the whole thing up, I already put everything alright. Well, I hope it is alright. So I have to select the Uno, and I have to select Uno as a port, then select monitor, and then I should be able to see something appear that says SPI test. And when I do not see that, something is wrong with the wiring. And honestly, something is wrong with the wiring, unfortunately. Totally wrong. So right now it doesn't do anything. So this one should go in here and stay there. And yes, this is a bit of a problem with all those wires. It just won't stick. That is one. And it goes out again. So right now SPI certainly won't work, which is a problem, and I'll fix that off screen. And then you meet with a problem, because I have replaced the wire by a very long one. That is no problem, but then when I say alright, I want to see the serial monitor, it suddenly says ACM0 is not available, and it turns out that 0 has been reset to ACM2. So now, so I have to say alright, and not just, why doesn't it do that? Alright, now let's see. Yes, everything is alright now, and that means that no, I will have to select the appropriate port, monitor, and now I do get SPI. I hope. Yes. The only thing is now that I need to put this probe onto it, or more appropriately this probe. Which I hope will work. Yes, it still works. But do I get a nice signal? Not really. Alright, so this shows that I still have to figure out quite a few things about SPI in combination with the oscilloscope in combination with SPI. No problem. And this concludes this video. Thank you for watching. What did I do? Well, I did do some pulse width testing on the motors, and that went quite fine, I think. Then SPI, and that was a bit more cumbersome, well, still is, but I'm on the right way anyway. So if you like this video, please subscribe or like, and you can also follow me on Twitter and Instagram. Please donate so the videos can keep coming, and more information on donating on my website, where you can also find lots of other stuff for such as pictures, etc. And this is obviously going to be continued. Bye bye.